Okay, we're going to do a system review real quick, and then we're going to get into the FIFO buffer. I'm going to code that from scratch. We're going to raw dog it line by line. So let's start with how we get to the FIFO buffer. So it's going to be transmitted through this ultrasonic transducer. That's the transmit. That's the receiver. There's the clock. It's 100 megahertz. We have to use counters to change the clock timing so that it occurs on a 10 millisecond, not 10 nanosecond count, because this transducer doesn't read that. It needs a longer signal. Then we go to the producer. This is the main part we're gonna emphasize on, how the producer and the consumer talk to the FIFO. And we're using a 32-bit count yet right now. We're not changing that anything. We're going to go line by line, how to create a FIFO in Verilog, and how the producer and consumer talk to Verilog. And let's go right to this real quick. This is the synchronous FIFO. The synchronous FIFO, this is a little bit of an overview. The synchronous FIFO has one clock. One clock. The right pointer tells you where to write next. These are your addresses. So in this case, we have 25 different addresses. Right pointer, what address we write to next. Read pointer, which address we read from next. Now the count. The count is how we tell if this memory array is full. Full is 26. Why 26 and not 25? Because we're starting counting at 0. We have to count 0. So at 26, the register is full, and at 0 it's empty. But what happens if it's not at either of those? I'll show you that right now. So if the right pointer equals 22, read pointer equals 20, count equals 2. All right, now let's get into the coding of this starting now. All right, so in our FIFO, what we're going to do here, synchronous FIFO. We're going to declare our ports. What ports do we need? Which are coming in? We have our input wire, our clock input wire. We need to do a reset. We know this. Now, what's coming in to the FIFO? We've got data in. We've got the 32 bits coming in. And then those 32 bits need to come out. Out. So that's our data out. What else do we need? We need our write enable. That's going to be coming. Those are inputs. Can I write? The producer asks, hey, can I send you info? Can I send you data? Can I send you data right now? That's the write enable. The read enable, the consumer asks, can I read? Then we need our full and empty. Those are outputs. The FIFO will say, the FIFO tells the producer, I'm full, don't write to me. The FIFO tells the consumer, I'm I'm empty. Don't read anything. So data in. Data out. What's next? Right, enable. Those are inputs. Full empty. These are outputs. All right. Now we have our internal registers. So this is, we have 31 bits of data, 32 bits of data. And we have a memory of, we're going to say, this is the depth. How many slots? $26. So this is 26. So we're using just like this. The count is 25. Their addresses, there's 25 addresses, but the count is 26. Remember that. They're not the same. Addresses and the count. Count is 26. So this is 26. The depth. Now we need our count. We need to do a, so it's a count of 5 bits. Count because 26 fits into 4, 8, 16, 32. Now we need to do the count. That's 4 bits. The right pointer. That's 4 bits. 5 bits too. Ay, ay, ay. And the read pointer is also 5 bits. Ah! I want to change that every time. Now we need to assign full and empty. So full, the count. It's 26. Empty is 0. Okay, let's start the clock. Now we need to reset everything to 0. all these internal registers we set to 0, and we've got to reset the data out to 0. Count right pointer, read pointer, and the data out. Okay. Now we need to write data to an address. Address is the right pointer. Then we need to wrap the right pointer from 25 to 0. So it'll wrap around. Then we need to increment the right pointer by 1. So just to look, we're going to write to each address, and then when it gets to 25, it's going to go to 0. Then it's going to count 1, 2, 3, 4, 5, 6, 7, 8 again, just like we previously discussed. Okay. Now to do that, you need to be able to write to it, so it's got to have the write enable. Hey, can I write? Yes. All right. Are you full? No. All right, begin. Cool. Then it's got a wrap. If it gets to 25, the address 25, we're done, son. Wrap me around. All right. Oh, I forgot to write to the address. We need to write to the address. Got to put that. Which slot? What's the depth? The date, and what are we writing in the date? It's got to be the data in. That's the data. Write data to an address. So there's data in to the address that has the depth of 25. All right. If the right pointer is full, set the right pointer to 0. Increment by 1. So if it's full, write the data in. If it's 25, set it to 0, else write increment by 1. So read logic. We just do this the opposite way. read enable and not empty. Read enable not empty begin. Data, we read data out. We read out. Write in. Read pointer. Wrap the read pointer to 0. Okay, that's the read pointer. Now we got to do combine. Now we got to do count and combine all the read and write combinations. Like if you want to read and write at the same time in the it's not full or empty. Is not full or empty. So remember, this is the count. And also on this one, we're going to be writing. We need the count. And so if it reads, it's going to read one away. So if you do another write here and it goes to 23, but you don't do another read, the count would be 3. So that's why you have to subtract from the read count. All right, so if write enable and not full and read enable and not empty. Begin. Count stays the same. Now we're going to count. We're going to increment for the right pointer and decrement for the read pointer, like I just said. Now do and not empty. Now let's decrement. Decrement subtract, right? Looks right. Let's check it. This is a using right pointer for count. Let's see what I messed up. Oops, okay, well. First, this is wrong. It's not 5 bits out. It's 32 bits out. That's first mistake. Second mistake. Oops. Got a random else if here. What the heck? Hold on a second. Uh, this is the count right here, count right here, but I'm not using right pointer here. I'm using right pointer there. I should be using count. I should be using count there. I used to, and these aren't supposed to be else if. No else. That's this has to be 32 bits. Is this supposed to be count plus 1 and not read pointer plus 1? Yep, definitely. Duh. That's I knew that. This is not supposed to be right pointer and read pointer. I'm doing the count. So, yes, this has to be count. And that has to be count. This is the count. Duh. And this is the right pointer. That's the read pointer. That's the right pointer. These are your addresses, write addresses. These are your read addresses. This is the count. That's it. Hope you learned something. Deuces.